So if you and I are both, fundamental observers in a quantum universe, the strict mathematics of radical relativism suggest we can never truly agree on the exact same reality.
Right, it's a completely decentralized picture.
Exactly. The facts that crystallize for you, they don't inherently crystallize for me. There's no absolute, I don't know, Newtonian ledger sitting under the floorboards of the universe keeping our histories in perfect sync.
Yeah, no master clock, no master spreadsheet.
Right. Yet, despite that dizzying ontological isolation, we are sitting here engaging in a shared, rigorously structured conversation about the philosophy of physics. I mean, the macroscopic world holds together for you, the listener.
It does. Empirically, it obviously does.
Today, we are unpacking precisely how that holds together, or, well, more accurately, the structural crisis that threatens to tear that macroscopic coherence apart. We're talking about combination problem.
And this is arguably the most urgent foundational crisis facing relational quantum mechanics right now. I mean, it really is.
This math.
It is, because if we take the core premise of RQM seriously, that every fundamental particle is an observer, and that dynamic properties only actualize relationally during physical interactions, we immediately run into a scaling problem.
Right. The scaling problem, because how do you get from a particle to a person?
Exactly. How do the discrete relative facts of a trillion microobservers combine to constitute the unified empirical reality of a complex macroobserver? If we can't mathematically and philosophically justify that combination, the whole relativist project it risks collapsing into mereological nihilism.
Completely. And our mission in this deep dive is to navigate this exact crisis.
Yeah.
We're going to examine a really rigorous, highly anticipated dialectic that has just unfolded in the literature.
The Riedel paper.
Yes. Our primary text is Timotheus Riedel's 2025 paper, published in Foundations of Physics. It's titled Composite Observers, Empirical Adequacy, and the Combination Problem in Relational Quantum Mechanics.
It was a brilliant piece of work.
It is. And it doesn't exist in a vacuum, right? It's a direct, systematic deconstruction of a recent, highly influential manuscript by Emily Adlam.
Yeah, Adlam essentially argued that orthodox RQM just cannot survive the combination problem, not without fundamentally altering its postulates.
Right. And Riedel steps in to demonstrate that orthodox RQM is actually far more resilient than Adlam gives it credit for.
Yeah.
But, and this is a big, but only if we're willing to accept some profoundly counterintuitive shifts in how we define human experience. And, relative probability.
Which we will get into. It gets weird.
Oh, it gets so weird. The terrain we have to map out today is dense. We are going to trace the growing schism between what we'll call orthodox RQM and the newer, heavily modified RQM plus framework.
Which is a crucial distinction for anyone working in this space.
Definitely. From there, we'll interrogate the metaphysical divide between liberal and restrictive approaches to system combination. We'll plunge directly into the mind-body problem as it manifests within quantum reference frames. And finally, we will confront a deeply problematic structural issue that Riedel identifies, one that Adlam actually missed.
The tensor combination issue.
Exactly. Regarding the combination of quantum states and probabilities. Okay, so let's unpack this, starting with the exact nature of the schism. Because before we can evaluate how microscopic facts aggregate, we need to precisely define the baseline ontology of RQM.
Right, the stuff they actually agree on before everything goes off the rails.
Yeah. Because the baseline is already a radical departure from classical realism, and from Everetian frameworks, for that matter.
It is. So the shared foundational tenet here is the austere, sparse ontology of the theory. In RQM, physical systems do not possess determinate dynamical properties in isolation.
Like a particle doesn't just have a position.
Exactly. A property, whether it's position, momentum, spin component, it doesn't exist as a freestanding element of reality. It only actualizes or acquires a determinate value strictly during a physical interaction between a target system and a witnessing system.
And we refer to these actualizations as flash-like.
Flash-like, yes, they are instantaneous. The continuous, smooth evolution of the Schrödinger equation that just describes the evolution of probabilities, but the actual physical events are a discontinuous sequence of these relational instantaneous flashes.
And crucially, quantum states themselves are stripped of their absolute ontological status.
Completely.
They're strictly relative. They're basically just bookkeeping devices, right?
Yeah.
Encoding the transition probabilities for future interactions.
Yes. Bookkeeping devices for specific systems. But The most democratizing and honestly the most metaphysically volatile tenet is how RQM defines an observer.
Oh, this is the best part.
Yeah.
Because it's not a guy in a lab coat.
No.
Yeah.
In this framework, the capacity to generate a relative fact requires zero cognitive apparatus, no macroscopic decoherence environment, no human intentionality. A stray electron is an observer.
A molecule of atmospheric nitrogen is an observer.
Exactly. A dachshund is an observer. A highly complex biological organism is an observer. It's an incredibly elegant ontological flattening.
It is elegant. But it's also exactly what invites the combination problem. I mean, if the nitrogen molecule is an observer with its own set of relative facts, and the constituent atoms of that molecule are themselves observers.
With their own relative facts.
Right. Then whose facts constitute the real history of the universe?
That is the million-dollar question. And to answer that, we have to look at how the RQM community has fractured over the concept of intersubjective agreement, which traces back to Carlo Rovelli's original 1996 formulation.
Which we're calling orthodox RQM, the unadulterated radical relativism.
Exactly. Orthodox RQM insists upon an almost vertigo-inducing level of isolation. If system S and system S prime interact, system S acquires a determinate property relative to S prime. However, and this is key, it does not necessarily acquire that property relative to any other system, S double prime.
The fact is entirely private to that specific interaction.
It's a private fact, and the regress doesn't stop there. The concept of higher-order relativity dictates that the very existence of the fact, the proposition that S has a specific property relative to S prime, is itself an observer-relative proposition.
Wow.
Yeah. There is no absolute God's-eye vantage point from which you can tally up all the relative facts. There are absolute facts nowhere.
Relative facts all the way down.
Vertigo-inducing.
It really is. But this radical isolation, it created immense pressure within the philosophy of physics community, didn't it? Critics argued it basically bordered on solipsism.
Oh, heavily. They said it rendered scientific confirmation impossible. I mean, if your measurement outcome is merely relative to you, how can we establish an objective, intersubjective body of scientific knowledge?
Right. How do we do science if my facts aren't your facts? And so, in response to this pressure around 2023, Adlam and Riedel introduced RQM plus V.
Which I tend to view as the tamed version of the theory.
Tamed is a good word for it. RQM plus attempts to walk back from the precipice by introducing a new, highly consequential postulate. Cross-perspective links, or CTL.
Yes, CPL. Let's define the mechanics of CPL precisely, because it's vital.
Go for it.
The postulate essentially states that if observer Alice measures a variable, and observer Bob subsequently measures Alice's physical pointer variable, say, the neurons in her brain or the ink in her notebook, the results must match.
Which, on the surface, sounds trivial, right? Like a basic demand for empirical consistency.
It sounds trivial, but the philosophical cost is enormous. RQM Plus elevates this consistency to an absolute coordination. It postulates that there is an absolute fact of the matter that Alice's relative outcome and Bob's relative outcome are synchronized.
It's a massive ontological concession.
Massive.
By introducing an absolute CPL, you're severely restricting the radical relativism that gave RQM its unique identity in the first place. You are essentially declaring that while individual properties are relative, the correlations between certain macroscopic records are absolute.
And critics, and Riedel places himself firmly in this camp, argue that this sneaks absolute facts back into the theory through the back door. You're sacrificing theoretical purity to artificially guarantee cross-observer coherence.
It kind of feels like a failure of nerve.
A failure of nerve. I like that.
I mean, think about it. If orthodox RQM is a multiplayer video game where the game engine only renders what is strictly relative to each player's local hardware,
Right.
then RQM Plus feels like suddenly insisting there's a master server room printing out absolute ledgers of everything.
Right.
If the universe doesn't have an absolute reference frame, why would it possess an absolute mechanism for coordinating relative frames?
That is exactly the core of the deflationist objections. And this specific tension over whether coordination must be absolute or relative is exactly what triggers the combination problem. Because if we are trying to construct a macroscopic observer out of a vast ensemble of micro-observers, we have to determine how the facts of the constituents combine.
Right. Does the macro observer only emerge if its parts share absolute links? Or is mere physical aggregation enough?
Adlam formulates this by importing the combination problem from the philosophy of mind, specifically from the panpsychist literature.
Oh, where they struggle to explain how, like, micro-consciousnesses bind together to form a unified macro-consciousness.
Exactly. But here, the focus is strictly on physical reference frames and relative facts. She breaks the crisis down into two deeply entwined subproblems: system combination and structure combination.
Let's define the parameters of those because they are the battleground here. System combination asks a fundamentally mereological question. Under what physical circumstances do micro-reference systems successfully combine to form a macro-reference system?
Yes. What is the ontologically necessary and sufficient condition for a collection of scattered particles to be recognized by the quantum formalism as a unified observer?
And then structure combination, on the other hand, asks an inheritance question. Once a macro system exists, how does it inherit relative facts from its constituents? Like, if a single photon interacts with one quark in my retina, does I, as a macro observer, instantly acquire a relative fact about that photon?
Right. And Riedel approaches this with what he terms the default view. We'll refer to it as the liberal package.
And liberal is almost an understatement. It is maximally permissive.
It really is. Regarding system combination, the liberal package asserts that any arbitrary collection of fundamental particles constitutes a valid composite reference system. There are zero spatial, temporal, or causal constraints.
Zero.
A collection consisting of a dust mite on Earth, a specific hydrogen atom in the Andromeda galaxy, and a loose electron in the center of the sun. That is a perfectly valid observer in the quantum formalism.
And its approach to structure combination is equally unconstrained, right?
Oh, yeah. The liberal package states that if an external system possesses a determinate property relative to at least one constituent of a composite system, then it mathematically possesses that same determinate property relative to the composite system as a whole.
So if that single hydrogen atom in Andromeda interacts with a local photon,
the entire Earth-Andromeda sum composite observer instantly inherits a relative fact about that photon state.
okay, so what does this all mean? Because to human intuition, an intuition trained on evolutionary biology and classical thermodynamics, that just seems like metaphysical chaos.
Yeah.
It completely ignores the highly structured, thermodynamically bound nature of what we normally consider an observer.
It does. And Adlam recognizes this chaos. That's why she proposes the restrictive CPL package as the necessary antidote. She argues that mereological permissiveness destroys the explanatory power of the theory.
So what are her rules?
Her restrictive package dictates that microsystems only successfully form a macro observer if they have engaged in extensive internal communication. Specifically, they must have come to share a vast network of relative facts via CPL-style interactions.
So the macro observer only emerges through active physical coordination.
Exactly.
Furthermore, regarding structure combination, the composite system only inherits facts that have been distributed and shared among its constituents via these specific absolute coordinating interactions.
So Adlam sees the macro observer as a hard-won physical achievement, a structure built out of absolute informational links. While Riedel sees the macro observer as nothing more than an arbitrary coordinate choice.
Right. And to fully grasp why Riedel is so comfortable with the liberal package's apparent chaos, we have to examine the underlying philosophical debate regarding the ontological status of macroscopic facts. I mean, are macro facts real additions to the universe or just shorthand?
This brings us to the divide between anti-deflationist and deflationist ontologies within quantum mechanics. Adlam's approach is intrinsically anti-deflationist. Meaning, in an anti-deflationist view, macroscopic facts represent additional, robust physical structure. When a composite system inherits a fact, something new has entered the ontological inventory of the universe that is above and beyond the microfacts themselves.
Oh, I see.
And if you hold this view, the liberal package is a nightmare because it implies an infinite proliferation of overlapping arbitrary macrofacts just cluttering the universe.
But Riedel advocates for the deflationist view.
He does.
And a deflationist argues that a macroscopic fact is not a new ontological entity. It's merely a coarse-grained summary, a convenient linguistic or mathematical shorthand we use to describe highly complex patterns of microscopic facts.
Right.
So if a macro fact is just an aggregate of microfacts, then system combination isn't a physical threshold, it's purely conventional. Grouping the Andromeda atom with the earthly dust mite doesn't burden the universe with new physical laws or entities. It's just one way of drawing a boundary on a piece of paper.
And this is deeply supported by the tensorial structure argument in standard quantum formalism. The Hilbert space of the universe is described as a vast tensor product of the Hilbert spaces of fundamental systems.
The math itself.
Yes, the mathematics allows you to factorize this total Hilbert space in infinitely many arbitrary ways.
Yeah.
You can group any subsystem A with any subsystem B. The purely formal structure of quantum mechanics is completely blind to biological organization, spatial proximity, or causal history.
Doesn't care.
It doesn't care at all. When we demand that a dachshund is a privileged observer, but a random cloud of gas is not, we are projecting our macroscopic evolutionary prejudices onto a formalism that simply does not recognize them.
So Riedel is essentially saying, if the math allows arbitrary factorization, the ontology of RQM must allow arbitrary observers.
Yes.
But Adlam looks at this mathematical permissiveness and basically says, if we accept this, RQM loses all connection to the empirical reality we're actually trying to explain.
Right. She thinks it goes too far.
Way too far.
Mm.
So she mounts 3 major, highly structured attacks on the liberal package. She's attempting to prove that it leads inevitably to the Evereshian and many worlds interpretation, which is the very thing RQM was designed to avoid.
The ultimate boogeyman in this debate.
Exactly. Let's analyze these attacks rigorously, because they are fascinating. Adlam's first line of attack is the conceivability argument.
Right. It's a variation of the classic philosophical zombie argument, but applied to quantum reference frames rather than consciousness.
Oh, like Chalmers zombies.
Exactly like that. She posits that we can logically conceive of a universe where all fundamental microsystems exist, and all their micro-relative facts obtain perfectly, but where absolutely no macroscopic facts exist.
Okay.
And because this scenario is logically conceivable, she deduces that the existence of macrofacts must require some further component beyond mere aggregation. And for Adlam, that further component is the absolute synchronization of cross-perspective links.
But wait. If we grant Riedel his deflationist ontology for a moment, how does that reframe Adlam's first objection? Because if a macrofact is literally defined as nothing more than a specific configuration of microfacts, the conceivability argument collapses entirely.
Yes, it does.
You cannot conceive of having the exact microstructural arrangement of a chair without having a chair. The chair isn't a further component added to the wood, it is the arrangement of the wood.
It's just a labeling issue at that point.
Right. Furthermore, couldn't we turn the conceivability argument against Adlam's own restrictive package? I mean, couldn't we easily conceive of a universe where microsystems share relative facts via her CPL interactions, yet still magically fail to form a composite macro observer?
We absolutely could. Conceivability is famously weak at dictating physical ontology.
It really is.
And Riedel makes exactly that counter-argument. Conceivability is a blunt instrument. Adlam's second attack, however, is a bit more functional. She raises the meaninglessness objection.
The meaninglessness objection. Let's hear it.
She argues that arbitrary collections of scattered particles, our Andromeda dust mite composite, cannot perform measurements in any philosophically or scientifically meaningful sense of the word. They can't act jointly as a unified apparatus. They can't record data coherently. So therefore, it is meaningless to assign them the status of an observer.
Okay, but this objection seems to smuggle a massive amount of classical Copenhagen-esque baggage back into the definition of measurement.
It absolutely does.
Because RQM's entire revolutionary premise was to strip the concept of measurement of its intentional, macroscopic, and thermodynamic connotations. In RQM, a measurement is simply a physical interaction where the dynamical variables of one system become correlated with the variables of another.
Yes. It requires no cognitive record. It requires no thermodynamic irreversibility.
Precisely. If a photon scatters off the dust mite on Earth, the physical state of the Earth-Andromeda composite has dynamically changed because a subsystem of it has interacted. The composite has, by the strict definition of the RQM formalism, measured the photon. It doesn't need to publish a paper about it to qualify.
No, it doesn't. Adlam is demanding macroscopic agency where the formalism only requires physical interaction.
But Adlam's third argument, this is the real crucible. It's the problem of the many, and it's the mechanism by which she believes the liberal package inevitably triggers an Evereshian catastrophe.
Yes, this is the big one. Let's break down the mereology of this. Consider Alice, a macroscopic human observer. Under the liberal package's arbitrary factorization rules, there is no single uniquely privileged collection of particles that defines Alice.
Right, because of the fuzziness.
Right. There is the collection of all particles currently inside her epidermal boundary. But there is also a distinct composite observer consisting of Alice minus one skin cell. There is another composite observer consisting of Alice minus a single carbon atom in her left eyelash.
Ah, ship of Theseus kind of stuff.
Very much so. And because these are all slightly different collections of particles, the liberal package must grant them all the status of distinct composite observers. There are billions of overlapping, nearly identical macroscopic reference frames occupying the space we casually refer to as Alice.
Billions of Alices.
Yes, this is a known paradox in classical mereology. It's often illustrated by Peter Unger's problem of the many regarding clouds, but Adlam applies it to quantum reference frames to devastating effect. Devastating because if we assume, as Adlam and many orthodox critics do, that different observers in RQM have totally disconnected, isolated sets of relative facts, then these billions of overlapping Alices occupy billions of isolated realities.
This is the critical juncture right here. Think about what happens in an experiment. If Alice performs a Wigner-style spin measurement, her macroscopic brain state should register the outcome. But because there are billions of distinct Alice composites, and because they are not bound together by Adlam's absolute CPL synchronization, what prevents Alice -1 eyelash from registering spin up, while Alice -2 eyelashes register spin down?
Oh, wow. If the facts are perfectly relative to the specific composite, the formalism doesn't seem to forbid it.
It doesn't, and if it doesn't forbid it, then a single quantum measurement by a macroscopic human fractures the local reality. Every possible outcome of the quantum superposition is actualized and experienced by some version of the overlapping composite observers residing in that chair.
That's Everett. That is Everett. Orthodox RQM, which was designed to be a single-world interpretation rooted in relationality, violently devolves into a bizarre, localized version of the Everetian many-worlds multiverse. The multitude of Alices experience a multitude of irreconcilable worlds.
And Adlam concludes that the only way to avert this Everetian nightmare is to mandate her restrictive CPL package, forcing all those overlapping composites to synchronize into a single shared absolute reality.
Exactly. She sees absolute CPL as the only dam holding back the Everetian floodwaters.
But Riedel, defending the liberal package, he can't use absolute CPL. That's against his rules. So he has to demonstrate that the dam isn't necessary because the floodwaters are an illusion. He has to prove that the billions of overlapping Alices will naturally agree on the outcome of the experiment, using only the native, unadulterated mechanics of orthodox RQM.
Yes, and what's fascinating here is that to do this, Riedel has to completely deconstruct the fundamental assumption underlying Adlam's fear. The assumption that cross-perspective communication in orthodox RQM is inherently impossible or contradictory.
Okay, let's look at this.
Adlam assumes that because facts are relative to the observer, observer A is permanently walled off from observer B's reality. Riedel argues this is a profound misunderstanding of higher-order relativity.
Let's lay out this naive assumption of solipsism clearly, because honestly, it's incredibly persuasive upon first glance. The argument goes like this. Bob measures a spin 1/2 particle. Relative to Bob, the particle's wave function collapses. He acquires a definite fact, let's say spin up.
Right.
However, relative to Alice, who is standing outside the laboratory and has not yet interacted with Bob, the unitary evolution of the Schrödinger equation remains unbroken. For Alice, Bob and the particle have entered a complex, entangled superposition. Therefore, Bob possesses a definite fact, and Alice possesses a superposition. Their realities are logically irreconcilable. What is true for Bob is demonstrably false for Alice.
It sounds like an airtight proof of fractured realities, doesn't it?
It really does. It sounds impossible to resolve.
But Riedel points out the fatal logical error in this proof. It attempts to compare Bob's facts and Alice's facts from a view from nowhere. It tries to hold both perspectives simultaneously in an absolute ledger. But orthodox RQM explicitly forbids this. The proposition Bob has a definite fact is itself a relative proposition. You cannot ask whether Bob's facts and Alice's facts align without specifying the reference frame from which you are conducting the comparison.
So to make a comparison, we must introduce a third party.
Exactly. We need a reference frame that encapsulates both Alice and Bob. We need the Charlie scenario.
The Charlie scenario. Let's rigorously define Charlie's perspective. Charlie is an overarching observer modeling the entire laboratory system. He observes a sequence of physical interactions. First, Bob interacts with the spin 1/2 particle. Second, Bob interacts with Alice. He physically communicates the result of his measurement to her.
Yes. And we must look at the mathematical evolution of the state vector, strictly relative to Charlie. Charlie applies standard linear quantum mechanics to the entire process. Before the measurement, Charlie assigns the particle a superposition state, alpha up plus beta down. Bob and Alice are in their respective initial ready states.
So relative to Charlie, the initial state of the total system is a tensor product. Yeah. The particle superposition times Bob ready times Alice ready.
Exactly. Now, Bob measures the particle. Relative to Charlie, Bob and the particle become entangled. The state evolves via a unitary operator. So we get alpha times, particle up tensor, Bob sees up, plus beta times, particle down, tensor, Bob sees down. All of that tensored with Alice still in her ready state. Notice that relative to Charlie, there is no collapse yet.
Right.
It is a vast superposition.
Right. Charlie hasn't measured anything inside yet. Next, Bob communicates with Alice. They interact physically. The unitary evolution continues relative to Charlie. The entanglement spreads to include Alice's physical memory state. So the final state vector, relative to Charlie, this is the crucial piece of mathematics. It becomes alpha times, particle up, Bob sees up, Alice hears up. PLUS beta times, particle down, Bob sees down, Alice hears down.
And that final equation is the death blow to the solipsism argument. Look at the tensor product structure of those branches. In the first branch, the particle's up, Bob's record says up, and Alice's memory of Bob's report says up. In the second branch, they all say down.
There's no mix and match.
Exactly. There is absolutely no branch in that superposition, zero probability amplitude, where Bob's record says up, but Alice's memory of Bob's report says down.
The linearity of the quantum formalism itself strictly forbids it.
Precisely. If Charlie decides to interact with them, if he measures Bob's notebook and then measures Alice's memory, he is mathematically guaranteed to find perfect correlation. Relative to Charlie, Alice and Bob's facts line up flawlessly. Therefore, CPL, the cross-perspective link, is not something that needs to be added as an absolute external postulate. Internal CPL is mathematically derived from within orthodox RQM itself, as long as you evaluate it from a specific overarching perspective.
That's incredible. Let me conceptualize this using a localized video game analogy because I think it helps. Orthodox RQM is not a global Newtonian engine processing an absolute universe. It operates more like localized computational rendering.
I like that.
When Charlie steps into the computational boundaries of the Alice-Bob system, the local unitary operators meticulously calculate the entanglement based on their physical interactions. The mathematics ensure that whenever Charlie queries the system, the records generated by Alice and Bob are perfectly dynamically correlated for Charlie. There is no absolute master ledger coordinating them from the outside, but relative to any observing frame, the internal subsystems are flawlessly synchronized.
That is exactly the ontological structure Riedel is revealing. Orthodox RQM possesses internal coherence. We do not need RQM plus absolute links to do science or to confirm intersubjective reality because relative to any scientist conducting an experiment, the instruments and the colleagues will mathematically agree.
So Riedel successfully fends off the threat of solipsism and meaninglessness.
He does.
But we are still left with the specter of Adlam's third attack, the problem of the many Alices. Because Charlie looks at the chair and sees a macroscopic human. But according to the liberal package, Charlie is formally observing billions of overlapping mereological composites. Alice, Alice minus a cell, Alice minus an eyelash.
Right.
Now, because of internal CPL, Charlie's math guarantees that if he queries Alice, or if he magically queries Alice minus an eyelash, they will both give him the exact same measurement result for the spin experiment. But a profound, disturbing philosophical question remains here. Do all these billions of distinct composite systems possess their own distinct conscious minds?
And this is where Riedel makes his most philosophically explosive maneuver. To diffuse the threat of a billion localized conscious minds overlapping in a single chair, Riedel has to attack a deeply entrenched, almost invisible assumption in the philosophy of quantum mechanics. It's an assumption shared by Adlam, Ravelli, and nearly everyone working in the field.
The assumption is the direct identification of experience with relative facts. The literature assumes that an observer's conscious experience is literally constituted by the set of facts that obtain relative to them.
Yes.
Under this assumption, the facts relative to Alice are the building blocks of Alice's mind. And since Alice minus an eyelash is a distinct reference frame with its own distinct set of relative facts, it must logically possess its own distinct conscious experience.
It is a seductive assumption. I mean, if you are building a relativist ontology, it makes intuitive sense to localize the mind within the frame of the observer. But Riedel argues this is a category mistake. He proposes what he calls the naturalist alternative.
The naturalist alternative. Let's break that down.
He argues that in naturalistic philosophy of mind, we do not identify consciousness with abstract relational coordinates. We assume that a conscious experience, like seeing the color red or registering a spin-up result, corresponds directly to the physical dynamical state of a macroscopic body, specifically the neural architecture of the brain.
Okay, so the supervenience of the mental on the physical. My subjective experience of reading a dial is supervenient on the specific biochemical firing patterns in my visual cortex. That is standard physicalism.
Yes, but now we must apply standard physicalism to the ontology of RQM. And in RQM, the physical state of a body is not an absolute property. The specific biochemical firing pattern in Alice's visual cortex is a dynamical property, and therefore it only actualizes relationally. The physical state of Alice's brain only exists relative to some other observer.
Oh, wow. The implications of that are staggering.
Aren't they?
If my mental state supervenes on my bodily state, and my bodily state is strictly observer-relative, then my conscious experience itself is observer-relative.
That is the radical naturalist shift. There is no absolute freestanding entity called Alice's unified experience. There is only Alice's experience relative to Bob, which supervenes on Alice's bodily state relative to Bob, and there's Alice's experience relative to Charlie, which supervenes on her bodily state relative to Charlie.
Here's where it gets really interesting, and honestly, epistemologically terrifying. But before we get to the terror, let's acknowledge how beautifully this solves the mereological problem of the many.
It's a very clean solution.
It is. If Charlie is observing the cluster of particles in the chair, the fact that he can mathematically parse that cluster into Alice, or Alice minus a cell, is just classical mereological fuzziness. It's like being unsure exactly which water molecules constitute a specific wave on the ocean. Because Charlie only sees one unified physical brain state actualizing relative to him in that region of space-time, there is only one conscious experience supervening on that physical state relative to him.
Yes.
The billions of mathematical composites don't generate billions of ghost minds. They're just arbitrary overlapping descriptors of a single coherent relative physical process.
Exactly. By decoupling experience from the abstract set of facts relative to frame X, and instead attaching it strictly to the physical state of body X relative to overarching frame Y, the multiplication of conscious minds evaporates entirely. It reduces a devastating quantum paradox back into a banal classical problem of boundary definitions.
But the cost, the epistemological cost, is immense.
Well, yes.
If we accept this naturalist shift, we lose the privileged sanctuary of the first-person perspective. Think about the introspective void this creates. If I'm currently having the conscious experience of speaking to you, and that experience only exists supervening on a bodily state that is actualizing relative to an external observer, how can I possibly know which observer I am currently having this experience relative to?
You can't.
Introspection is blind to the reference frame. Am I experiencing this deep dive relative to you, the listener, or relative to a stray cosmic ray passing through the studio walls?
This raises an important question. How does a continuous, coherent inner narrative survive in a universe where the underlying physical substrate of the mind is continuously flashing in and out of existence relative to a chaotic multitude of external reference frames?
It sounds impossible.
Riedel acknowledges this is deeply counterintuitive. An experience Alice has relative to a stray photon is just as ontologically real as an experience she has relative to herself. But he argues this epistemological humility is the unavoidable price of genuine relativism. If you want to purge the universe of absolute facts and avoid the Evereshian multiverse, you cannot demand that your own consciousness remains absolute. You must relativize the mind itself.
Wow. And this philosophical debate over the nature of experience directly determines the criteria for the next major battleground, empirical adequacy. For a physical theory to be viable, it must be empirically adequate. It has to predict and account for the world as we actually observe it. Adlam argues that orthodox RQM fails this test miserably when confronted with the preferred basis problem. So let's unpack the mechanics of this failure. What is the preferred basis problem here?
Well, the preferred basis problem arises from the mathematical underdetermination of quantum interactions. When two systems, S and S prime, interact, RQM states that a property actualizes. But the formalism does not automatically dictate which property actualizes.
It doesn't pick out what's being measured.
Exactly. It does not select a unique basis in the Hilbert space. If you attempt to use standard extraction procedures like a Schmidt bi-decomposition on the joint state, you run into severe degeneracy issues.
Right, degeneracy.
If the Schmidt coefficients are degenerate, which, by the way, is incredibly common in realistic continuous variable Hamiltonians, the decomposition fails to pick out a unique orthogonal basis. It leaves you mathematically adrift.
What does that mean in physical terms, though, for the listener?
It means that during a single interaction, The mathematics of RQM might allow a fundamental particle to simultaneously acquire a determinate value for position and a determinate value for momentum relative to the interacting observer.
Oh, wow. It allows for the simultaneous actualization of non-commuting observables.
Exactly, which is fundamentally non-classical.
Adlam looks at this and establishes her criterion for empirical adequacy. She calls it the incompatible facts constraint. She states that an interpretation of quantum mechanics is empirically inadequate if it entails that macroscopic human experimenters could simultaneously possess knowledge of incompatible observables.
Which is a very reasonable demand.
Very reasonable. Because clearly, empirical reality as we know it never involves seeing a particle with perfect position and perfect momentum simultaneously. Adlam argues that only her RQM plus package, using the absolute coordination of CPL combined with environmental decoherence, can force macroscopic systems into a classical commuting basis.
She essentially argues that the master server of absolute CPL is required to rigorously enforce classical logic on the macro scale.
But Riedel.
But Riedel, having already proved that orthodox RQM possesses internal, perspective-dependent CPL, dismantles this constraint entirely. He demonstrates that relative to any overarching observer modeling the macro system, internal CPL allows orthodox RQM to harness the exact same decoherence mechanisms that Adlam relies upon, like Zurek's unselection.
Oh, right.
The environmental scattering of photons relative to Charlie will rapidly suppress the off-diagonal elements of the reduced density matrix for Alice's brain state, picking out a stable, preferred basis. Adlam's restrictive package has no monopoly on decoherence.
Furthermore, Riedel leverages his naturalist alternative to redefine the constraint itself. He proposes the disallowed states constraint.
Tell us about that.
He argues that if conscious experience supervenes on physical bodily states, we shouldn't care what abstract relative facts exist in the mathematical ether. The only thing empirical adequacy requires is that macroscopic human bodies never evolve into a physical state relative to an external observer, where they simultaneously physically encode incompatible properties.
And the physics of decoherence guarantees exactly that.
Yes.
The mathematics of RQM might permit a single quark to possess simultaneous incompatible facts relative to another quark. The microontology can be as wild and non-classical as the underdetermined math allows, but the macroscopic physics of a human brain, heavily interacting with its environment, mathematically prevents the brain from entering a physical state of registering those incompatible facts.
The empirical adequacy of our daily experience is protected not by artificial constraints on the quantum ontology, but by the raw thermodynamics of the brain's physical structure.
Exactly. It's a stunningly effective defense. Riedel navigates the mereological chaos of the liberal package. He neutralizes the zombie argument. He dissolves the many Alice's problem into classical fuzziness via the relativization of mind. And he proves that orthodox RQM flawlessly replicates empirical reality via relative decoherence.
It appears the liberal package has achieved total victory.
It does.
But just as the dialectic seems resolved, Riedel introduces an entirely new, deeply structural crisis. He identifies a fatal flaw in the formulation of RQM that Adlam entirely missed. Yeah. And it threatens to tear down both the liberal and the restrictive frameworks.
Yeah, this is the curveball. We are transitioning from the conceptual combination of facts to the rigorous mathematical combination of quantum states and probabilities. And this transition exposes a massive gaping hole in the predictive mechanics of relational theories.
We can call this the underlying structural crisis. It breaks down into two interrelated subproblems, state combination and probability combination. Let's construct the specific scenario Riedel uses to expose this flaw, because it's really clear when you map it out.
Let's do it.
We have three entities, a macroscopic observer Alice, a macroscopic observer Bob, and a microscopic spin 1/2 particle, P. Let's stipulate that Bob performs a precise measurement on the z-spin of particle P. Alice is physically present in the laboratory, but she has not yet dynamically interacted with either Bob or the particle.
Okay. According to the fundamental tenets of RQM, we must assign states strictly relationally. Relative to Bob, he has interacted with the particle, a relative fact has actualized, and the particle has collapsed into a definite eigenstate. Let's assume Bob measured spin up, so the state of P relative to Bob is up.
Pure state.
Pure state, yes. However, relative to Alice, who remains isolated from the interaction, the unitary evolution continues. From her perspective, Bob and the particle are in an entangled superposition. If she wants to calculate the state of particle P relative to herself, she must trace out Bob's degrees of freedom, leaving her with a mixed state, a reduced density matrix, SURU.
So we have a pristine contradiction in state assignment based on perspective. Relative to Bob, the particle is in a pure collapsed state. Relative to Alice, it is in a mixed state superposition. So far, this is standard, unproblematic RQM. But here is the question that breaks the framework. What is the mathematically precise state of particle P relative to the composite macroscopic observer Alice Keogh SS Bob?
It is a devastating inquiry because quantum states are not just descriptive labels, they are the mathematical engines we use to generate predictive probabilities for future physical interactions via the Born rule.
Exactly.
Suppose a passing external system, say a stray photon, is going to interact with the composite system Alice plus Bob. To predict the outcome of that interaction, the universe needs a state assignment for P relative to the composite. Which mathematical object does the formalism instruct us to use? Does the definite pure state of Bob mathematically override the mixed state of Alice? Do they average out? What happens?
Let me conceptualize this using an analogy of scaling distinct actuarial risk models. I think this helps ground the math. Imagine Bob and Alice run separate, fiercely independent insurance firms. Bob investigates a specific house and determines with absolute certainty that it is not on fire. His risk probability is 0%, a definite state. Alice has not investigated the house. She only has historical data showing a 5% chance of fire. Superposition state. Now, Bob and Alice are forced to merge into a single corporate entity, Alice plus Bob. And a reinsurer demands a single unified risk probability for that specific house to underwrite a new policy. How does the newly merged entity mathematically combine a 0% certainty with a 5% superposition to generate a coherent joint probability measure?
You can't just mash them together.
No. If the underlying data is entirely perspectival, what is the mathematically rigorous protocol for combining conflicting localized probabilities into a predictive macroscopic model?
And the terrifying answer is, RQM provides absolutely no protocol. The formalism is entirely silent on how to integrate these tensor spaces when states conflict.
Wow.
The liberal package, which enthusiastically insists that Alice plus Bob is a valid observer, collapses because it cannot assign a coherent state or calculate a probability for the composite it just validated.
And it destroys Adlam's restrictive CPL package as well.
It does. Adlam might argue that Alice plus Bob isn't a valid observer yet because they haven't shared CTL lines regarding particle P. But what if we introduce particle X and particle Y?
Okay, expand on that.
Suppose Alice and Bob have extensively measured particle X and communicated their results perfectly. Under Adlam's rules, this robust CPL communication promotes them to a valid composite macro observer, but they have not communicated about particle Y. Bob measured Y, Alice didn't. When the valid composite observer, Alice plus Bob, is asked for the state of particle Y, Adlam's framework encounters the exact same mathematical undefinedness.
If we connect this to the bigger picture, this is not just a niche puzzle relegated to RQM. This exposes a fundamental scaling problem for any interpretation of quantum mechanics that attempts to relativize states or probabilities to localized observers, if those observers can themselves be subsumed as parts of larger macroscopic systems.
Exactly. If the theory cannot formally scale local probabilities into a unified macroscopic probability measure, then the theory cannot mathematically predict the macroscopic world. It breaks down precisely where we need it most.
The crisis seems totally intractable. You can't simply patch the Born rule to accommodate logical contradictions. But in the final sections of the paper, Riedel offers a highly non-standard, mathematically aggressive mitigation strategy. It is a radical reconceptualization of the relative state.
It's his Hail Mary.
Walk us through this mitigation strategy. How does Riedel force the probability structures to align?
Riedel argues that to avoid mathematical contradictions when calculating composite probabilities, we must abandon the attempt to construct composite states from the bottom up. We cannot take Alice's local information and Bob's local information and try to glue them together.
Because they conflict.
Right. Instead, we must describe the entire scenario top-down, from the perspective of an overarching observer, which we will call O.
Okay, we're bringing Charlie, or O, back into the mix. We're establishing an external reference frame modeling the whole laboratory.
Yes. And here's where Riedel alters the standard interpretation of the eigenstate-eigenvalue link within RQM. Let us assume that relative to O, the physical interaction between Bob and the particle has occurred, and O registers that Bob's outcome is spin up, or state up. Riedel proposes that relative to O, the objective state of the particle relative to Bob is up.
That tracks.
But simultaneously relative to O, the objective state of the particle relative to Alice is also up. And therefore, relative to O, the objective state of the particle relative to the composite Alice plus Bob is uniformly up.
Wait, I just stop you there. This completely contradicts the standard narrative we established earlier. We explicitly said that because Alice has not interacted with the particle, the state relative to her is a reduced density matrix, a superposition. Now, you are saying that relative to O, the state relative to Alice collapses into the definite up state before she even interacts with it.
That is exactly the radical shift Riedel is proposing.
Well,
And it requires a profound rereading of what a relative state means in the formalism. Riedel points out that if Alice were to calculate her own state, based purely on her local ignorance, she would indeed write down a mixed density matrix rho.
okay.
But O possesses a more complete mathematical model of the entanglement. O's model mathematically guarantees that if Alice subsequently interacts with the particle, she will 100% register the spin-up result, because the particle is already definitively correlated with Bob's record in O's frame.
Oh. So Riedel is decoupling the state of the particle relative to Alice from the epistemic information Alice currently possesses.
Precisely. He is arguing that the relative state is not a representation of Alice's local knowledge. It is the objective, predictive probability of what will happen in a future interaction, as judged by the overarching perspective of O. Because O knows with absolute certainty how Alice's future interaction will resolve, O assigns her a collapsed, definite relative state immediately.
So if it is definite for Bob, and it is definite for Alice, then the state for the composite Alice plus Bob is smoothly and unambiguously definite. The actuarial conflict vanishes because the overarching underwriter recognizes that Alice's 5% probability model is simply based on incomplete data and replaces it with the 0% certainty derived from the global model.
Exactly. The composite state is unified across all subcomponents by the predictive power of O's perspective. The mathematics never force the universe to divide by zero or average, contradictory, pure, and mixed states, because from the perspective of the overarching frame O, the states of all the subcomponents are harmonized prior to the composite calculation.
But I must push back violently on this. Is Riedel not simply recreating a wave function collapse that happens simultaneously for everyone, everywhere, mimicking absolute mechanics? Does this not completely dismantle the spirit of relationality and sneak a quasi-absolute observer, the master server room, right back into the core of orthodox RQM? We spent an hour establishing that facts are private interactions.
It is a totally valid concern. It's the most critical vulnerability in his defense. And Riedel works hard to clarify that this is not an absolute collapse. We must remember that this harmonization is entirely perspective dependent.
Okay, explain.
O is not God. O is not the absolute Newtonian background. O is merely the specific reference frame we chose to perform the composite calculation. If we had chosen Alice's pre-interaction frame instead, the entire mathematical landscape shifts. From Alice's frame, the particle is in a superposition relative to her, it is in a superposition relative to Bob, and it is in a superposition relative to the composite Alice plus Bob.
I see. So the state assignment changes depending on the overarching frame, but the internal consistency of the assignment within that frame remains absolute.
Yes. The point is not that O possesses the ultimate truth. The point is that within any chosen overarching frame, the composite state problem vanishes because the mathematical state is unified across all internal mereological subcomponents relative to that specific frame. The framework survives the structural crisis, but only by demanding that we always calculate probabilities from a specified overarching coordinate system and never attempt to build them bottom up from isolated local facts.
It is a staggering conceptual maneuver. It forces us to accept that the very probabilities defining the future of macroscopic systems are only mathematically coherent when anchored to an external observing frame. Which brings it to the end of what has been an incredibly dense, rigorous, and mind-expanding exploration of the limits of quantum ontology. Let's briefly resynthesize the dialectic we've mapped today for our listeners. We began with the profound foundational crisis of the combination problem. How do microscopic relative facts aggregate into macroscopic reality?
We examined the deep schism between Adlam's restrictive anti-deflationist CPL package, which views macro-observers as physical achievements built from absolute coordination, and Riedel's liberal deflationist package, which treats composite observers as arbitrary tensor factorizations of the Hilbert space.
We navigated Adlam's mereological attacks, the zombie arguments, and the terrifying specter of the problem of the many Alices fracturing RQM into an aberration multiverse.
We then witness Riedel's meticulous defense, demonstrating that orthodox RQM naturally generates internal cross-perspective coherence through the linearity of entanglement, rendering absolute links mathematically redundant. We explored the radical naturalist shift, redefining conscious experience as supervenient on observer-relative bodily states, effectively dissolving the many-Alice's paradox while opening a vast epistemological void regarding our own introspective access to reality.
And finally, we confronted the underlying structural crisis, the mathematically intractable problem of composite state assignment and probability scaling, a crisis Riedel could only mitigate by aggressively reinterpreting the relative state as an objective, predictive probability anchored strictly to an overarching reference frame.
For those of us entrenched in the philosophy of physics, this debate represents the bleeding edge of quantum interpretation. It forces us to confront the ultimate limits of relativism. Can we build a coherent, empirically adequate macroscopic world using only locally generated, uncoordinated relative facts? Or do the mathematics of probability and mereology eventually force us to rely on overarching frames and absolute synchronizations to keep the universe from unraveling?
It challenges us to decide how much intuitive classical ontology we are willing to sacrifice to maintain the pure relationality of the quantum formalism. And as we conclude, I want to leave you with a final, highly speculative thought to mull over, building upon the radical epistemological shifts we discussed today. Throughout his paper, Riedel explicitly brackets out the problem of quantum self-description. He deliberately avoids the paradoxes that arise in Wigner's friends scenarios, where observers attempt to mathematically define their own reference frame.
Yes, he restricts his analysis to third-party overarching observers modeling subsystems.
But let us combine the two most radical propositions Riedel has presented. First, conscious experience only exists supervening on an observer-relative bodily state. Second, the quantum state and the predictive probabilities of a composite macroscopic body are only mathematically coherent and well-defined when evaluated relative to an overarching external observer O.
The implication there is deeply unsettling. It implies that an observer's internal self-description is fundamentally mathematically incomplete or incoherent.
Exactly. If the physics of my macroscopic brain, the very substrate of my mind, cannot be assigned a coherent state, without generating fatal probability errors unless viewed from a higher frame, does that mean the unified coherence of my own conscious experience is mathematically contingent upon being observed? Does the strict formalism of RQM imply that we require an external observer not just for objective science, but to mathematically guarantee the mereological coherence of our own inner lives?
It brings us full circle to the very heart of the quantum measurement problem. We sought a framework that would allow the universe to actualize itself through self-interaction, free from absolute backgrounds.
And instead, we discover that the macroscopic patient lying on the ontological table might only mathematically hold together if the overarching doctor is continuously watching the scan.
A truly profound structural crisis.
Thank you so much for joining us on this deep dive. Until next time.